So today I want to make a quick video to help out the people that have been gone for track and other reasons. As we start in with the last chapter we're going to be looking at this year, which as you can see here is going to be about what we call conic sections. Conic sections are just shapes that you can make by slicing a cone in different directions. The idea is that you take a cone, like this thing, and if you slice it in different directions, you can get things like a circle in one direction, or if you go at an angle, you get an ellipse, like an oval shape. You can actually cut at a little bit more of an angle and you get a parabola. And there's a fourth shape that's called a hyperbola that kind of looks like you have two parabolas that are sort of mirror images of each other. That's the idea of the different conic sections that we're going to be learning about. You can also define conic sections in terms of distance, and in fact today distance is the main thing that we're going to be talking about. So I said there are four conic sections. You should already have a little bit of an idea of what a circle is, and we're going to be more specific about what makes a circle as we go later on in this chapter. Earlier this year, we learned about parabolas that have like a U shape or an upside down U shape. The biggest application of parabolas is in problems that involve gravity in different ways. And you can picture if somebody's shooting a basketball, it goes up, it comes down, and it makes that parabola shape. The third conic section is what we call an ellipse. An ellipse is like an egg shape, an oval shape. And one of the biggest applications of it is that the orbits of all the heavenly bodies, like the moon in this picture, or all of the planets, orbit in an elliptical shape. The fourth conic section is a hyperbola, which, like I say, looks kind of like you have a parabola and another parabola that are mirror images of each other. Parabolas are used a lot in construction. Hyperbolas are used a lot in construction. And that's because for any given amount of material, you can get the greatest strength with a hyperbolic shape. There's all kinds of things that you may not expect, like the nuclear plant cooling tower in the picture, that are hyperbolic. I mentioned before that all the conic sections are defined using distance, and because of that, we're going to take some time today to review the distance formula that actually comes up in Algebra 1. It's what you use to find the distance between 2 points. If you think of one point as being like x1, y1, and another point as being x2 and y2, you can use those numbers to plug into the distance formula to find out exactly how far apart those points are. And while the formula sometimes looks complicated, it's actually not all that difficult. What this is saying is you subtract the x's and square, you subtract the y's and square, you add them up, and then you take the square root. That's what the distance formula says to do. Subtract each part and square, add them up, take the square root. It's really just a very complicated way of saying the Pythagorean theorem, because what you get when you subtract the x's is just like the bottom of this triangle. What you get when you subtract the y's is like the height of the triangle. And you know that one side squared plus another side squared has to equal the hypotenuse squared. There's two kinds of problems that you typically see with distance. One of them simply gives you a couple of points and says find the distance between these. And basically you're given x1, y1, x2, and y2, and you've got to plug them into that formula to come up with your answer. So I'm going to subtract my x's and square, I'm going to subtract my y's and square, add them up, and take the square root. And here you can see exactly that happening. The order that you subtract in doesn't matter. I just need to make sure the x's are together and the y's are together. Here I did do the second x minus the first x and the second y minus the first y. But I could have just as easily done 5 minus negative 2 and 7 minus 4, and I'd get the exact same answer. You can write the answer as the square root of 58, or you could write a decimal like 7.6. They're both perfectly correct. The other kind of problem you have is almost like you're playing Jeopardy. Here they're telling you that the distance is 5, and we need to figure out what's the missing value here. What would x be in a point so that I got a distance of 5? Well, what I do is I plug in what I know to the formula. I know that the distance is 5. And I know I get that by subtracting the x's and squaring, so x minus 7 squared, plus, then I subtract the y's and square, and I add them up and take the square root. Now what I did here is I simplified what was under the square root. I took 2 minus 5 was negative 3. You square that, you get 9. And then to get rid of the square root, I squared both sides. 5 squared is 25, and when you take a square root and square, it just cancels out the square root. What I'm going to do to finish this off is I'm going to subtract 9 on both sides. And then I'm going to take the square root and finish solving for x. And here's the rest of that problem. If you subtract 9, you get 16. Square root of 16 can either be 4 or negative 4. It can be either of those answers. And if you take 4 plus 7, you get 11. If you take negative 4 plus 7, you get 3. There's always going to be two answers to problems like this. The idea is that one of these is going to be 5 units one side of your point, the other one is 5 units the other side of your point. And so both of those are correct answers that we'd have. Now, our assignment today is a worksheet that deals with using the distance formula, and then all of the different conic sections as we learn them will be defined using distance, which is why it's important to know that.